Okay, guys, so if you take out your little review sheet, the one-page review sheet, I summed this up on 2 boxes. I did a whole box on passive transport and then active transport because there's a lot of scenarios they could give it to you. Okay. So, I'm gonna just read what I gave you on this kind of review sheet, and then we're gonna go over on the board. We're gonna go over a couple scenarios. Okay, so passive. When you're passive, you're relaxed. You're not using energy. When you're active, you're using energy. Okay? So whenever you get these situations and they talk about using energy, the answer is always active transport. Whenever it's not using energy, it's passive. Okay? Okay? So let's start off with passive. Okay? First one is diffusion. When you diffuse, you spread out. Okay? It's natural. You don't have to use energy to just spread out. So say if I had some smoke in my mouth and I blew it out, the smoke would diffuse. It would spread out. And if you notice the concentration, ready? It would go from a high concentration in my mouth, and it'd be kind of like high concentration outside of my mouth, and then it would spread out to the low concentration. So diffusion is when you go from a highly concentrated area, and then you get to be free, and you get to just go into a low concentrated area. For example, right now, where is more crowded? In our class or in the hall?
In our class.
I don't see nobody in the hall. I see one person in the hall.
Oh, no,
So guys,
no.
if it is 2, 4, 6, 7 people in here versus 1, which direction would we go and not have to use any energy? Outside, because we're going from a highly concentrated classroom to a low concentrated hallway.
I thought you meant not during class.
Well, now then we'll flip it. Okay, so now let's switch it. There's one other scenario. We'll talk about that. Active transport needs to do energy. Needs energy. So that would be like the opposite. If the bell rings and there's a bunch of people out in the hallway, you have a highly concentrated hallway. You have a classroom with only a few kids. If you had to fight your way into the hallway, you would need to use energy. Okay? So when you go from a low concentration into a high concentration, that's using energy and it's active. Okay? So you're going against the crowd, against the flow. Okay. Now, small particles, they just can go back and forth without energy. Large particles need energy. Okay? This is the only exception, guys. Okay. You know how the cell membrane is made up of lipids, the fatty acid glycerol layer? It also has protein tunnels that help things go in and out. Okay? So sometimes you have these medium particles, and as long as they're going with the flow and not going into crowded areas, they could just go in through the tunnels, and that's called facilitated diffusion. It has diffusion in the title, so it's obviously diffusion and no energy. Okay. So, go into this. We're almost done too.
Okay.
Okay. So, we have diffusion, particles moving from a higher concentration to a low. Example, if you put a drop of food coloring in something, it diffuses, the particles go from high to low, okay. And then the other form of diffusion is water, and this is a little bit more complicated, but remember, your body is made up of 70% of water. If water took energy to flow, we would be using a lot of energy, so it doesn't. Now, water always goes to the party, or the particles, so that's like when you eat a lot of sugar or salt, you feel bloated, you retain water, because guess what? Water goes to those particles. So, water, osmosis is the movement of water, okay? Passes through a selectively permeable cell membrane, okay? Remember, cell membrane is selectively permeable, it's choosy, it doesn't let everything in, it doesn't let nothing in. This is the other thing I want you to put somewhere on here about the cell membrane, because I forgot it. I'm gonna add it to your next review sheet. So this is what I want y'all to add. I don't care where you add it, but you could just circle this, circle cell membrane, and then write made of lipids. So the lipids is the membrane part, and proteins. And then I would draw an arrow to the tunnel. So do that right now. Okay.
Okay, what is the picture of?
So this is the cell membrane. So like for example, here would be a nucleus, here would be the ER, here would be the Golgi, okay? So the lipid is the cell membrane. The protein is the protein tunnels that allow things to come in and out.
Oh.
Alyssa, bring me these sheets because I staple your sheet onto this packet. Okay, so then this is what I want to say about osmosis. Okay, so you got isotonic on here. I write the word same. Remember, iso means same, like isosceles triangle, same sides. So isotonic cells or isotonic situation means there's the same concentration on the inside and outside. So if there's the same concentration, whether it's 1, 2, 3 particles on the outside, 1, 2, 3 on the inside, whatever amount of water goes in, the same amount of water comes out because this cell is equal. It's in homeostasis, okay? The cell membrane maintains homeostasis, okay? Hypertonic. Kids that are hyper are moving really fast. I think you're hypertonic, okay? They're usually skinny, okay? So always think to yourself, hypertonic, what kind of cell is that? Well, that's a cell that's supposed to shrink. Now, why would it shrink? Something would shrink if water would leave it. So if water is going to the party, there must be a lot more particles on the outside and maybe just a few on the inside. So the water's going to the party, leaving the cell, and the cell is shrinking. Then you got hypotonic, hypo, like a big fat hippo. Why would something come in and make it swell? There must be a whole bunch of particles on the inside, okay? So you got your 3 situations. So for example, they're gonna ask you, okay, I'll leave this up. So this is a hand and it's in salt water. So have y'all ever been in the ocean and then you get out and your hands are shriveled? You're like, this is disgusting, okay? Well, the ocean took some of your hydration. The ocean took water out of your hand. There are more particles outside of your hand, so guess what? It drew the water out. Your hand started losing water and your hand became hypertonic, okay? So, fish tanks, we always talk about fish tanks, okay? If you put a saltwater fish in a freshwater tank, where's the party? Inside of the fish. Where's the water gonna go? Inside of the fish. What is that going to cause the fish to become? Hypo. Good, and it's going to die. Okay, reverse. You got a freshwater fish in a saltwater tank. Where's the water going to go?
Out.
Out to the party. It's going to cause the fish to lose water, and it's going to become hyper. Okay, so this is what we're talking about during these. The only other thing that I want to show you is so they do have questions that kind of look like this, okay? You have something right here. This right here is 98% water, okay? How many particles are in it? 2. So remember, it always is out of 100. So if that's 98% of water, it's 2% salt, 2% sugar, whatever it is. Well, say if this is distilled water. Does it have anything else in it?
No.
No. So this is 100% water. So now you got 2 particles on the outside, none on the inside. What direction is the water going to go?
Out.
Good. Now let's cross this out. We'll say this is actually 95% water. How many percent particles does that mean?
5.
Okay, concentration change. Now which direction does the water go?
In.
Okay, inside, good. Water goes to the party. Okay, good. Okay, almost done. Active transport, besides stuff going against the gradient, so like you going into a crowded room, one glucose trying to go into a cell when you already have 10 glucoses in that cell. Okay, this is active transport. Look it, we got like 30 particles up here, and then there's only about 10 down here. If you're trying to shove more particles into the crowded area, that's going to require energy. But if you're one of these particles wanting to go into the lower, less dense area, then that's passive. Okay, the other two is, it takes a lot of energy for the cell membrane to open up and to engulf something or to expel something. It's kind of reminding me of pimples, but okay, so say if this is a bunch of glucoses or starches that your cell really wants, they'll all come to the cell membrane and the cell membrane will engulf it. It does take a lot of energy to do that, so it's endocytosing, bringing it in. Okay, this is a bunch of waste. Maybe it's waste that the lysosome broke down, maybe it's waste that it didn't, but we gotta get it out. Opens up, so it takes a lot of energy to do that and to get it out. So those are also active transports. Okay? So I'm just gonna do this first one with you to show the importance of drawing stuff out when it comes to osmosis, okay? So, when a sea urchin egg is removed from the ocean and placed in fresh water, I'm going to draw that out. Ready? Here's the fish tank. A sea urchin egg is removed from the ocean, so I know the egg is salty. And then the fresh water is not. The egg becomes which of these? So, water goes to the particles, water goes to the party. Which direction is the water going to go? Into the egg or out of the egg? Yeah, because look at the party, all the little particles, that's where we want to go to the party. So what is the shape going to be?
Big.
What is that called?
Hypo.
Good. So, when in doubt, draw it out, okay? And so you do have about 15 questions here. Do these at your seat. I'm going to check on you in a couple of minutes, and then we'll go over them.